This is a study of gaze as an anticipatory cue of the targets of human walking motions. We develop a classifier that improves on prior work which uses head orientation to predict where study participants will walk early in their trajectories by incorporating gaze. We hypothesize that gaze allows us to make these predictions at the same level of accuracy, but earlier in the walking path. In prior work, Onelkar et al. Present a classifier that leverages head orientation to predict the target of a person's walking path. Prior work from our group leverages a similar gaze cue to indicate which side a robot intends to pass a person on when navigating past them in a narrow corridor. The findings indicate that people more readily understand a gaze cue than an LED turn signal used by the robot. Here, we expand on Onelkar's work to develop algorithms to predict the target of human walking motions based on gaze. This study leverages a virtual reality system with eye tracking capability in conjunction with a body tracker placed on the participant's waist, which records high-fidelity motion data using 2 base stations within the study area. There are 5 goals presented in front of the participant, a start position and an intermediary position which they must walk straight through. The participant is told which goal to go to by a recorded digital voice.
Goal 1. You have reached the goal. Go back to the start.
This study's methodology has 2 basic goals: to develop a classifier to identify the target of the participant's walking motion, and to perform a statistical analysis to detect the earliest point at which gaze and head orientation are predictive of the goal of the participant's walking motions. A multivariate Gaussian time series prediction algorithm is used to predict the goal that each participant is heading towards. As shown in the figure, gaze yaw, represented by the blue line, predicts the goal with the highest accuracy of all parameters. This study uses multiple repeated measures ANOVA tests in combination with the Tukey test to determine which cue is the earliest predictor of the goal of the participant's walking motion at a statistically significant level. We confirm that gaze is the earliest predictor among head orientation, body position, and velocity. Please refer to our paper for full details. Previous works have shown head orientation to be an anticipatory feature of a person's trajectory, and people often look to the goal after which they reposition their head. This study shows that gaze is not only as accurate a predictor, but also an earlier predictor than head orientation. This research contributes to an overall goal of building a model for social mobile robots to successfully and comfortably navigate in close proximity to humans in restricted environments such as hallways.